Today is March 31st, and today we're going to start looking at vector addition, how to start working the next page of problems. Because the school announced a wellness day on Friday, and I'm very pleased about that, there is no class this Friday, April 2nd, so your official instructions are usually been. We will have normal class both days next week. And so Wednesday, we'll continue talking about vector addition and start looking at working other types of vector problems, like the velocity questions on the last page. We're going to keep working through on these. And because, to be fair across all of my lectures, I'm currently making this assignment due the 9th. So this assignment is due the 9th. We'll give out another assignment around that time, which I'm expecting to do around the 16th. Hopefully we'll be starting talking about things like Newton's laws. And both of these weeks will be normal class weeks for us, will be Wednesday and Friday. This second to last week of April, though, there's Honors Day on the 21st. So no class that day. So I'm currently planning our second and final normal test to be April 23rd. That will be on the 3 assignments from the last test. Been a lot of weeks and a whole lot of days that we weren't normal class, but that's fine. We're getting good material. I want this to be the last test day so that we can then spend the next week summarizing everything, going over the entire semester and the test before exam week starts, which is the first week of May. So, no class this Friday. Homework is currently due next Friday on the 9th. We'll have one more assignment before the next test. And no class on Honors Day. If that isn't a school rule, it needs to be a school rule. Because if I had Honors Day, I would not be able to take class. Any questions about the schedule and upcoming events? Okay. How do you guys feel about, any questions about the assignment parts that you've looked at and worked so far? Okay. Well, today we're going to begin looking at vector addition on page 2. And vector addition is, I look at it as kind of a puzzle, because every piece that's present needs to be broken down into its respective elements, combined in a very specific way to get to the answer. I am a very puzzly kind of person. I pursue puzzles to work them on my own in my free time. So I understand that this might not necessarily appeal to everyone, so I'm going to try to make it as straightforward as I can. Vector addition. I have a quick sort of sample up here. What is the vector displacement after someone walks 5 miles north, 3 miles east, 8 miles south, 10 miles west, and then another 5 miles north? I'm going to quickly sketch that, and I'm not going to do it under the board because I have a different problem saved back there. I'll do it over here real quick. So this is our origin. So 5 miles north, 3 miles east, 8 miles south, 10 miles west, and 5 miles north. After that entire journey, if someone was to walk this, they would end up in this spot. And we could look at figuring out where this person has wound up in two different ways. We could look at the scalar distance that this person traveled. And scalar distance, a scalar has no direction involved. So your car's odometer, or like a step counter that you have, tells you scalar distance. It doesn't care about the direction you moved in, it just cares about the total number of feet elapsed. So if we were looking at just the distance walked, like this person had a step counter installed, then we would just add all these numbers together. Walked 5 feet, then 3, then 8, then 10, then 5. That adds up to 31. So we could say this person walked 31 feet, and that could be an answer to just how far did they walk. But if this person was lost in the woods, would that help you find them? If you just knew from start this person walked a total of 31 feet, could you find them in the woods with just that information? No, because that doesn't mention direction at all. This person could be anywhere in a 31-mile radius. So instead, to be more specific about where you end up, we have vector displacement. So all vectors have a magnitude and direction. Scalar distance doesn't care about direction, but vector displacement does care about direction from start to finish. And to find the vector displacement in this particular question, we need to look at the direction of each of these pieces. And in general, for vectors, you can only add vectors together if they're in the same axis. If I'm jumping up and down, does that have any effect on how far back and forth I walk? No. My y displacement has no bearing on what I'm doing in the x-axis. So as far as vectors are concerned, you can't add this 5 and this 3 together because they're not in the same axis. The 5 and the 8, however, are in the same axis. So those add together to help us determine where this person wound up within the y-axis. So, to do vector addition, you want to look at all your vectors and determine how the x pieces add together, and separately from that, how your y pieces add together. So, for this whole journey, we have 3 x pieces. There's 3 parts of this in the x-axis. We have the 5, the 8, and this other 5. So only those 3 can add together within the x-axis to give us an answer. Will this tell us the answer we want if we just add 5 and 8 and 5? No. It's good instinct. The issue is the 5s both point north. The 8 points south. So the 8 is working against the other 2. So it's not always just about the axis. You also need to care about what direction within that one axis the number of points in. So in this particular case, there's a total of 10 miles north working against a total of 8 miles south. So the net distance in the, oh, I got my labels backwards. I apologize. Oh no, that was confusing. I'm so sorry. I made a mistake. I've been calling these X's when they're Y's. So sorry. I'm very sorry. The Y components are 5, negative X, and positive 5. And those should add together to 2 in the Y-axis. This person is now, from start to finish, a total of 2 miles north of where they started, which just tells us that piece. And what I've written here, 2 miles in the y-axis. You could, as a completely valid answer, write this as 2 miles north, as long as you are describing the magnitude and the direction in some way, shape, or form. It doesn't specifically matter which way you write it. Looking in the x-axis, we've got 3 and 10. The 3 is going east and the 10 is going west. Those work against each other. One of them is going to need to be negative. Typically speaking, on XY systems, we're just going to assume that east is positive and west is negative. So that would make a 10 negative using that particular system. And that's going to give us negative 7 miles in the x-axis, which you could additionally write as just 7 miles west. So for vectors, the negative just tells you backwards or forwards in the axis you're examining. So now, this piece tells us displacement in the x-axis from the start. So we've got 2 and 7, negative 7. And that ultimately can tell us our final answer. Because what we want to know is how far from start to finish are we? And what we found is the coordinate answer for where we wound up. I'm calling our final answer vector C, because C is what we usually call a hypotenuse. And since we have found that we are moving 7 miles in the negative x direction and 2 miles in the positive y direction, we can write our answer as a set of coordinates. We've gone this far in the x and this far in the y. And that is a vector answer. So that's one way you can describe what we found here. And for this particular assignment, that's all I'm going to ask you to do. If I ask you for a vector answer, this is an acceptable way to write it as a coordinate. In the future, we'll do this more often in Physics 1500. Just to go ahead and make you aware, in the future, we can also describe this as a number at an angle. And that would tell us specifically go this far in this direction to find this person. And essentially, what we built here is a triangle of sides 7 and 2. It is a right triangle because x and y are perpendicular to one another, which does help with the trig. And we can use a little bit of trig to figure out, what the hypotenuse of that triangle is, what direction it's pointing in, and that would just be a different way of writing the answer. But for right now, all I want for you guys on these assignments, will totally suffice as the answer, is the coordinate form. There was a lot of questions on this one. I want to save you a little bit of time. So let's see. For every problem on the second page asking you for the vector, all you need to do is give me the coordinates like that of the answer. And the same thing. You can do the same thing. 19, 20, 21. Yes, so for every time you're asked for a vector, you can give it in coordinate form. So, any questions so far? Okay. Now, let's apply what we've learned to a different case. Let's look at number 11 on homework. And I've already got that drawing worked up here. Now, there's a lot up here. We're going to talk about it one piece at a time. If I need to simplify any elements, redraw them, I gladly will. For number 11, our goal is to add two vectors together. We're adding vector A, which is listed as 4 miles in a direction of 30 degrees, and add that to vector B, which is 6 miles in a direction of 124 degrees. So when adding vectors, I like to draw them what I call tip to tail, which is to say that if I draw the first vector from start to finish, then the second vector being added to it, I start at the tip of the vector I just drew, and then from there I start with the tail of the second vector and draw it from there. So for graphically showing vector A plus vector B, I begin with drawing vector A, we've got 4 miles in a direction of 30 degrees up from the x-axis. Typically, if an angle doesn't specify, we can assume it is counterclockwise from the x-axis, the normal geometric standard. So drawing the first vector, just like this. We are then going to add B to it. And B, I recommend drawing B at the tip of the vector A that we just finished. So from this spot, if we draw vector B is described as 6 miles at 124 degrees. Now it would look like this. We did the first stretch, and we turned and done the second stretch.
Can you just estimate the angle? Obviously that's not exactly 30 degrees.
Right. For the sake of the drawings, I'm not going to ask you guys to be hyper precise. You can, for all of the drawings, work it as close as you reasonably can with just your eye. You don't need to break out a ruler and a protractor. The working graphically, I just want a good picture a decent picture representation showing the two vectors together and then showing separately the vector that represents the sum of the two. Because if we were walking this path, we did branch A, then we did branch B, the displacement from start to finish would be this red line. And that is the graphical answer. And we form a triangle. Unfortunately, it's not a right triangle, so there's no good rules as to solving it graphically without going into the right angle trig steps that we're going to employ. But all of the vectors on the assignment can be drawn this way. And number 11 looks like this. I want to go ahead and at least help you draw 12 and 13 since they're using the same A and B. I've got quick sketches over here. 11, I'm sorry, that one's 11. 12 is B minus A. So we start by drawing vector B, and then we need to subtract A from it. That I prefer to think of it as adding negative A. So what I would do then is, from here, once we've finished vector B, at the tip, draw what vector A would look like normally as a positive, and instead invert it, draw in the opposite direction. So I'm calling that B and negative A. And graphically, they would add together to form this purple line. Then, number 13, very similar, the main difference being that we're now multiplying two of them. So 2 times A would be a vector pointed at the 30-degree mark, but now 8 meters long. And from the end of 2A, we will draw 3B, negative 3B. Positive B will point that way, so negative B should point in the opposite direction. B is normally 6, so 3B is going to be 18. And that makes this purple line our final answer. So that's the setup for those 3. Those are the graphs for 11, 12, and 13. And those are that's all you need to show for the graphs. That said, I find the graphs very helpful in finding the numerical answer because the method I recommend for finding the numerical answer is taking what you've drawn and dividing every single one of these lines up into a triangle. This is going to be sort of a universal constant for all of physics, but any line can either be described as just a flat line in one axis. Say if you just go straight east, that's not really a triangle, but it is a flat line within one of the cardinal directions. If it's not in the cardinal direction, it can be described as a right triangle, with each of the legs of the triangle forming the x and y components of that triangle, and then the original vector itself forming the hypotenuse of that theoretical triangle. This is the method I recommend for finding the numerical answer of what vectors are added together. Because for each of the triangles involved, if we look at the xy components of vector A, the xy components of vector B, if we solve for the legs of these triangles, we can add the x components together, we can add the y components together, and that will tell us the xy components of the combined sum angle, line, excuse me. Questions so far before I start poking through my work up here for you guys? Okay. So for number 11, the lines that you would need are vector A, vector B, and this final answer vector that I'm calling C. Since we can only add numbers in the same axis, we have to figure out the x and y pieces of each of these vectors. Because along pathway A, these 4 miles, you're moving in the y and x direction at the same time. So the legs of the triangles tell us how far in each axis this person has moved while accomplishing the 4 miles at 30 degrees. So we know 4 miles at 30 degrees, and we know that x and y are perpendicular to one another, so we can form this triangle and use a little bit of trig to find its sides. If we did sine of 30, that would equal ay over the hypotenuse. That gives us a y component of 2. If we did, sine of 30 equals ay over 4. Cosine of 30 equals ax over 4. And that gives us these 2 components. These are the literal legs of the triangle. It tells us as we were going that 4 miles at 30 degrees, we traveled this far in the x-axis and this far in the y-axis. So more east than north. We can then do the same thing to vector B. And the way that I drew vector B and the legs of the triangle, the way that I drew it, the 124 isn't actually inside of the triangle I drew. So instead, I found the supplementary angle to 124. That means that the triangle would have an angle here of 56 degrees. 56 plus 124 is 180. You could redraw this any number of ways. I see 2 ways you could draw this differently that would get you the correct answer still. It doesn't have to be this way if you don't prefer it that way. Excuse me. But the way that I divided this triangle up, that puts a known 56-degree angle right here. The hypotenuse is 6. My blue marker died, which is why I switched to green. And we can do the same thing we did down here. I'll find the legs of this hypothetical triangle we've drawn. Sine of 56 should be opposite over hypotenuse. That'll tell us the y leg is 4.97. Cosine of 56 will tell us the adjacent x piece over hypotenuse. That tells us bx is at 3.36. Excuse me, sorry. Questions so far? Okay. So, we've now divided the triangles up into their components. We can now add the x components together and the y components together. So, let's see. Going over here, looking at the x components of each of the 2 triangles we're adding together. I'm just going to add the x components up. Something to factor in, though, is that for vector A, we're going northeast, so its x component points east. Vector B is going northwest, so its x component points west in the opposite direction of A's x component. So they're working against one another. That means one of them needs to be negative as we add them together. Since west is normally the negative direction, I've made that one negative, and that tells me by adding them together that C, the final sum vector, has an x component of 0.10 east. And so on the little lines that I've drawn for what C's components would be, Cx would be 0.10. And the picture is not exactly to scale, but you can tell that it's a small way. The 0.1 makes sense. The y directions will also add together, and thankfully, they're both pointing north. So they're both positive numbers. Those will add up normally. So 2 plus 4.97 should give us 6.97. So cy, the y component of c, goes that far north. And that tells us the coordinates for where we wound up, which is, as far as I'm concerned today, a vector sum. Which means that you can write your final answer in this form. This tells us exactly where this person is going to end up. So that is a final acceptable answer for number 11. How do you guys feel about 11? When I was printing the assignment, I left every piece one-sided, and you could put work and stuff on the back if you wanted to. Please feel free to use that space. I know that there's not exactly enough, there's nowhere near enough room next to each question for any of the work that goes into it. So please use the back of the page by all means. I'll refer to it while looking at your work. And 13 and 12 will be solved using the same methods, but to briefly look at each of these triangles here. Right now I'm just drawing in the divided up vector legs for each of these triangles, just to help illustrate a little bit. Oh, that's how you can be. So every single one of these questions will work the same as these. Similar to these. My standard recommended order of operations is draw them tip to tail, find the components of each of them drawn sort of like triangles, and add the like components together. Any questions? do you guys feel about this? Okay. This is good. Okay. That is everything needed to do page 2. Next Wednesday, we will address any issues you've been having and also look at any specific details needed for the 3rd page. And the assignment will be officially due next Friday. For right now, we can look a little closer at, say, 12, 13, and 14 if you guys like. Otherwise, that's all the information that we absolutely need for today. You guys feel all right? I asked the same questions over and over again. I apologize. I don't know if it's me being anxious or short-term memory loss. Probably both. I know we don't normally state the exact end of the period, but if we hang out the next 10 minutes, we can step through some of the trade for 12 and 13 if you guys like that. Unless you guys just want to break here. Which were you nodding at? All right, cool. Okay, where's my calculator? Now, students don't always have to put the legs in the same spots that I do. I tend to draw them out when I can so that they don't overlap with each other. Like rather than going into this middle point here, I try to pull them outwards so that there's no overlap. That's not always a hard and fast rule though, because sometimes I'll draw them to make use of what angle is known whenever I can. So how my drawings pan out is always going to be a little bit different each time. And you don't have to draw them exactly the same way. If at any point on any question, if you're, say, working on your own and you're wondering, did I draw this right? Is this going to work? Please feel free to just show me your drawing and I'll give you the thumbs up or not, because I don't want you to be worried about it and make a compounding mistake later on. So, let's see if I can get colors. Okay. So, for number 12, hypotenuse of B is still equal to 8. Hypotenuse of A is still equal to, no, sorry, it's 6 and 4, isn't it? Sorry about that. B is 6, A is 4. And for each of these, I try to draw it to make use of as many known angles as possible. However, it's a little bit tricky with this B because we were told the angle we know for it is 124 degrees from the x-axis. Not all of that is going to be in a right triangle starting with the y-axis. So how I would describe that is you subtract 90 degrees from that 124. You can describe this as 34 degrees from the y-axis. And that's the number that I'm going to use momentarily. So, for triangle B, we've got sine of 34 will tell us bx over b, and cosine of 34 will tell us by over b. So that gives me 3.36 in the x direction, and 4.97 in the y direction. Actually, the numbers we find here will be the same as the ones we found in number 11, because we haven't multiplied them yet. So it's mostly just a question of what axis they're in. It is worth noting this time that bx points in the negative x direction. It's pointing west, so that would technically make this negative. Meanwhile, for A, I drew it in a way to keep this 30 degrees so that we can use that. From that 30 degrees, sine of 30 will be a y over 4. And cosine of 30 will be a x over 4. And that makes our y component 2. But this time, as opposed to last time, that 2 points south. So that would be in the negative y direction. Meanwhile, the x component is still 3.46. And that is pointing west, so that's also going to be in the negative x direction. So to find the coordinate answer for vector c in this one, we want to add negative 3.36 to negative 2. That's the x coordinate. The y coordinate is going to be 4.97 minus 3.46. Then for 13, sine of 30 will give us a y over ax, sorry, a y over 8. Cosine of 30 will give us a x over 8. Meanwhile, b, sine of 56 will be y over 18. And cosine of 46, sorry, 56, I'm sorry, 56, x over 18. Times the sine of 30 is 2 times what we had before. So that's 4 in the y direction. Looking at vector A y is going to point north, so we can leave that for as positive. A x also points in the negative, in the positive x direction. So that can also remain a positive number. And we get 6.93 in the x direction. For vector 3b, we're going to have 18 times sine of 56. That's going to be 14.92 in also, sorry, this is the y piece. That y piece points vertically down, so b is headed southeast this time, so this y component will be a negative number, but the x component is still pointing in the positive x, so that will also remain positive this time.